Warm welcome. Good afternoon to all for this speech. So times for offshore wind are exciting and tough. They are exciting because there are two strong drivers for offshore wind, decarbonation, but also sovereignty. And there is growing social acceptance of a renewable future for all, as has been demonstrated recently in a votation in Switzerland where a significant majority voted in favor of boosting renewable energy. But they are also tough because the supply chain is extremely constrained and the raise of interest rates makes the investment case a bit more tricky. And except in the US, there is no financing scheme in place to ease that for the moment. So the aim of this speech is to present you the possibility, the solution, the opportunities to improve even further business cases for investors. What will also help the whole supply chain for offshore wind. In Hitachi Energy, so we provide electrical equipment for connecting offshore wind farms to the grid and integrating into the energy system. So for a sustainable energy future for all. And the first thing to notice is that wind business is indeed not wind business. Wind business is indeed electricity business. And therefore, it's very relevant to have that electrical angle to look at the opportunities. So let's first put the basis of this business. So why is offshore wind a very important piece of the future of energy? The first aspect is abundance. The technical potential of offshore wind, according to the World Bank, is 7 times the global electricity consumption, all sources of energy included. So even if, as the projections say, electricity needs, demand, will grow 50% by 2030 due to more electrification in transportation and in industry, and a bit, let's say, mitigated by better use of energy, we still have a lot of energy available if we combine wind, offshore, onshore, solar, geothermal energy, hydropower, and even nuclear in France. So abundance is there, and that's very important because there are sustainability needs like recycling, circular economy, taking care of biodiversity, changing the agricultural techniques that require energy. So it's a good news that there is abundant energy, especially in offshore wind. The second point is in terms of feasibility and scale. So offshore wind is a proven technology for bottom fixed and is an incremental technology for floating. Floating represents 70% of that potential. So that means it is absolutely necessary to go fast in the floating technology, both for the wind farms, but also for the substation and the connection. In terms of scale, you all know we are speaking about gigawatt level investment, what means it's not only possible to build scale in the business case, but also in the industrial setup. So that means it's really an opportunity for a country or region or a continent to grow in a new technology significantly. And this demand in offshore wind will stay at least until 2050 and even beyond. So that's another good news from offshore wind. Number 3, favorable time profile. So you know that, maybe you might know that in some projects we are now reaching 50% availability of offshore wind power, which is much beyond solar and even onshore wind. But on top of that, it's very complementary to solar and very complementary from one region to the other. So studies show that with up to 50% of offshore wind we need no, in Europe, we need no grid reinforcement, no taking into consideration the fact that there are already some planned. So we are already so much interconnected that we can cope until 50%. And then after, say we have the choice, either complementarity with other sources, storage, or more interconnections. And with more interconnections, we can reach close to 100% renewable penetration. And last but not least, it's very important, so there is much less competition for space offshore than onshore. Therefore, much better acceptance from the population to build the offshore wind farms than anything onshore. So all that shows really that this is an attractive market for investors. What are the design options? So the first thing to decide as an investor is what technology will I use? Then you have two choices. Alternate current, HVAC, direct current, HVDC. HVAC is very major, is cheap, is proven. You connect directly to the grid. There are some weak points, so you need more cables and you have more losses, so you cannot transport to so much distance than HVDC. But there is also one problem, which is this undersea cables. They generate a lot of reactive power. And then good news is there are large-scale compensation, power compensation equipment that is now available, like the static converter. HVDC is an amazing technology. So in HVDC, you can consider you have 1.2% loss for the conversion and 2.5% loss per 1,000 kilometers of line. So compared to 7% for AC. So it's really the technology to connect very large wind farms to the load. You don't even need to go to shore. You can directly go underground to the load. You can also perfectly control your reactive power, waveform, everything with the modern HVDC technology. Good news for both STATCOM and HVDC technology. They rely on power electronics, where Europe is by far the leader, the world leader in power electronics. Even the power semiconductors, they are produced in Europe in very modern plants. So it's really a trump card for Europe. The second big choice is floating versus bottom fixed. So bottom fixed is when you have low, let's say, water depths, let's say below 60 to 80 meters, which is the case of all the continental plates in the North Sea and the Baltic Sea, which is a very special asset for Europe to have this shallow water where there is significant wind. So it's completely proven and already developed at large scale. But as 70% of the potential require floating, we really need to consider it, especially all the Atlantic coasts and Mediterranean coasts require that technology, but also powerful countries for export, like Japan, Korea, US, East and West coasts require floating technology. So that's an important choice. There are many developers now having pilot projects or having won auctions with the floating technology. Again, a big opportunity for the supply chain. Regarding the wind turbine, there is no real roadblocker to have floating wind turbine. In terms of substation equipment, so all the power equipment, we are well on track to qualify all our equipment to additional mechanical stress linked to the movement of the waves and the current that floating undergoes. Okay, so it's almost ready, and it's also an amazing opportunity for the yards and the marine industry, which are local. So it's a way to revive or to boost the yards, because those floaters, they are huge and they need to be built quite locally. They cannot be transported too long. A very important decision-making point for investors is repeatability. So how can I learn from one project to the other so that the next project is always cheaper than the previous projects? And there are a lot of solutions. So to agree on standard designs, on base solutions with some vendors or some engineering companies is a way both to speed up the development of projects, but also to gain in quality by incorporating the lessons learned from the previous project. So I believe the base solutions, which are nice to have in many projects, here are a must-have, and they're even more must-have in floating, because there you have to interact with the floater designer. So there is a joint development of the optimal solution. The more the floater is big, let's say, the more stable it is, and therefore the less you need to reinforce your electrical equipment, and vice versa. So there is a trade-off there to be looked for. And also good news is that because the space is wide and there is no real limitation in terms of visual impact or things like that, so size matters. So we go to to bigger and bigger projects and bigger turbines. So you see the rating per turbine increasing, which is also an opportunity to switch to another level of voltage from 66 kV to 132 kV, saving on cable costs, saving on losses. There are also now projects in Europe of energy islands, which, let's say, concentrates several wind farms, potentially by several developers, on artificial islands, though so easy to build because there is no competition again, and then bringing the power to shore with a powerful HVDC link, can be 10 gigawatt or something like that. On top of that, you can locate on the islands big loads like data centers or hydrolyzers to save space on shore in countries where space is scarce. So there are some design choices that can really make a difference. The other big area of additional profit for investors as what is called hybridization of offshore wind, of hybrid offshore wind. That means combining offshore wind with additional revenue streams. The first, most obvious one is energy storage, so to take care of the variability of wind and potentially to play on the spot market, so to store power instead of being curtailed, or when power prices are low, when solar is high, for example, to sell it later on. And good news is that we see now worldwide large battery energy storage facilities, like in Olkiluoto, the nuclear power plant in Finland. They have a 90 megawatt battery energy storage for various reasons. So it gives flexibility and it gives grid services. The second big area where there is room for optimization is green hydrogen. So green hydrogen is a vector which is needed for decarbonation of industry and of some transportation means. And there is a great synergy between hydrogen generation and offshore wind. It's called green hydrogen. It's the only way in the future to produce hydrogen with nuclear, maybe. Huh? I don't remember the color of the nuclear. Is it pink? Pink, thank you. We have NCOE, so the network manager for Europe, has demonstrated that having some capacity of electrolyzer is really smoothing the demand and allowing to a more penetration of renewables. So for an investor, it's still a tricky decision because you need to size your, first choose the technology of the electrolyzer. You need also to size it in order to increase availability of the hydrolyzer compared to the wind farm, and to decide where to locate it. So it can be located close to the wind farm, close to the generation, and then be transported by pipeline, or can be located close to the usage of coal, close to the steel plant or the transportation hub. So there is a lot of optimization there, and such optimization requires also to understand a bit the grid, to understand what are the constraints on the grid, what is counted as green hydrogen, what are the curtailment moment that could come. So it's an interesting decision to take. The next way to increase revenue from offshore wind farm is to provide grid services. So, of course, we all know about reactive power grid services. This is compensation. This is remunerated in more and more countries. But we have also active power grid services. So with or without, but better with a little bit of battery, you can provide frequency support and you can provide black start of the grid easily. So that's another source of revenue. And last but not least, so as I mentioned, so more and more investors are now covering only a part of their production with a PPA or feed-in tariffs, and reserve another part to play on the spot market. So that require coupling between weather models and grid models, understanding the price of electricity. All that is available. We have software for that. And with this, you can really optimize your play with renewable, especially when bidding without feed-in tariffs is happening, as for example, recently in Germany. Okay. There is also another way to play to win is to manage a portfolio of renewable assets, to have wind farms, solar farms, other peakers, other generation, and to manage that as a portfolio of assets. So again, it's a sweet spot for software, for smart software. Not to mention digital technology. So it's really, we are just at the very, very beginning of harvesting the value of digital technologies. If you think that the life cycle cost of an offshore wind farm is typically 30% of the total cost of ownership, depreciated, and many of our partners, they believe they can save between 30 and 40% of costs, of those costs with digital solutions. So that means 30 times 30, 9% saving on the total cost of ownership thanks to those digital solutions. The first one is on project planning. Their digital twins are playing an instrument role. There are here some companies demonstrating some very specialized digital twins for logistics, but also for erection. I think we are all going to 3D modeling, BIM modeling. It can speed up and decrease the quality problems in project planning and building. Maintenance is an enormous, it was a very quiet area for the last 20 years, but now it's moving super fast with condition-based maintenance being now the norm. But the most advanced operators, they go to reliability-centered maintenance, risk-based maintenance, really optimizing their maintenance plan. This is very important for offshore wind because the substation, so the 1 gigawatt substation, is a common mode of failure of the whole wind farm. So if you lose one wind turbine, you lose 15 and in the future 20 megawatts. If you lose the substation, you lose the gigawatt. So reliability is super important. And also maintenance is difficult offshore. So it must be minimized. So what was a nice to have for onshore grid development, online monitoring, digital substation, is becoming a must have for offshore wind. So there is a lot of value to harvest there. The next step is the management of ecosystem of players. So you have in this exhibition a lot of startups or companies very specialized in bringing some value, optimizing the pitch of the wind turbines, optimizing movement of the ships, the crews. All that, let's say, is an opportunity to be integrated digitally in ecosystems that will replace the monolithic solutions that that are for the moment used by the utilities and by the gencos. So that's something very important to harvest as well. And those technologies are constantly evolving. So you have now semantic web technology, you have Industry 4.0, IoT technology coming into our industry, smart sensors, cameras with AI algorithm, all that is an enormous potential. Just think as generative AI used to capture all the maintenance knowledge on a wind farm, so that fixing an issue is faster and more efficient. So there is still a lot of sources of added value to harvest. I would just like to mention sustainability, because very often we just confuse sustainability with decarbonation only and CO2 footprint only. And it's much more than that, of course. So in terms of reducing the CO2 footprint, renewable itself is an amazing case, and we need to decarbonize the full life cycle of renewable offshore wind, so from erection to decommissioning. We have, for the grid part, so we are also replacing greenhouse gases like SF6 by less harmful gases, so decreasing the impact. But the first thing is not to harm humans and nature, not to harm animals, not to harm humans. So that means all the efforts we can do jointly as an industry to improve safety of working offshore, safety of erection of offshore wind farm, that we can respect the ecosystem. In that sense, for example, floating technology is much more friendly to nature than bottom fixed technology, where you need to, let's say, disturb the seabed animals. We have also leakages. There are a lot of aspects we are already doing which are super important for sustainability. And last but not least, the third part of the slide is reuse of material, the use of material. So it's a common challenge for our industry that it will use a lot of material, a lot of steel, a lot of concrete, a lot of copper or aluminum, for, let's say, the equipment, the mooring system and all that. So the only way to justify that is to say, yes, but it's only once, and we will recycle everything. So I think that's as important than CO2 reduction and the other ones. Okay. So this is the end of my pitch. So just to summarize, there are a lot of opportunities available now in technology to improve business case of wind investors. And it's not to do everything in one shot. The idea is to be ready for those new vector of value add. So to design and build wind farms which are ready for hydrogen, which are ready for battery energy storage, which are ready for grid services. This is the way to de-risk the project. So there are many ways to improve technology readiness and therefore decrease cost of capital by improving bankability of those projects. And of course to manage sustainability holistically. But for that, I think our very strong conviction is that ecosystems of partners must be built in the industry. So we cannot play the game of the mature industry, of a pure market play. Here it's really developing something new. So we believe that having a partnership approach is much more efficient, and Hitachi Energy is happy to partner with every company wanting to reach this sustainable energy for all. Thanks a lot and enjoy your afternoon.